So welcome back students to one more session of your qualitative analysis. So what did we do in the previous video? We have studied about the anion analysis, isn't it? Let me recollect what did I do. I've completed analysis of class 1 acidic radicals, class 2 acidic radicals and class 3 acidic radicals. I think students are busy preparing for the pre-boards. Please watch every video or every radical which I have picked up. I've taught you the procedure. I've taught you what is a viva question in that. I've also given you the reactions what you're supposed to write in the examination. So after the anion analysis, now let us start today with the basic radicals or the cation analysis. Very important part of, or the last or the second part of your qualitative analysis. So whenever I speak about cation, we very well know cations are positively charged particles, isn't it? Done. So in this positively charged particles, these are also called as basic radicals. Anion was called as acidic radical, cation is called as basic radical. So when your examiner asks you, they may ask you identify an acidic radical and a basic radical in the given salt. So don't get confused, it is nothing. You're supposed to analyze an anion and a cation and report to the examiner. Right. I've been getting so many doubts in the comment section saying, ma'am, should we do confirmatory test for everything? No, nothing. Don't get confused. Whichever anion or whichever cation you get a precipitate, that one only you're supposed to do the confirmatory test and retain the confirmatory test and show it to your examiner. Done. Let us start off with the cation analysis or the basic radical. First of all, what should we do? Now you have done your anion, you kept your anion confirmatory test and kept it on the test tube holder. Sorry, your test tube stand. After that, next you're left out with the salt. Now start with a cation. So when we do cation, the first important thing which you have to remember in your mind is the wet analysis. This is the most important thing which you are going to do. So what is this wet analysis? Basically in your wet analysis, you're going to see the solubility of the salt. So I have done, let us learn one trick, the easiest way where all the anions and all the cations are covered in that. So this is what it took a lot of time for me to frame everything and give it to you. So please memorize this and go. You will get, confirm in first 10 or 10 minutes maximum you can analyze the cation. What is that? Let's see for a while. So meta-analysis, I'll be teaching you, as I told you, solubility. How did I divide? I'm going to divide the solubility or the test tube or the salts which are soluble in water, the salts which are sparingly soluble, and the salts which are insoluble in water. Done. Insoluble in water. So basically, whenever we are doing this wet analysis, we see the solubility with cold water, we see the solubility with hot water, we see the solubility with dilute HCl, we see the solubility with HNO3 also. So HCl solubility and HNO3 very rarely they will not give you, and some they give you testing the solubility with aqua regia also, right? So these are the different acids which you will be testing, but the common salts are water soluble salts only which are given to you. Done. So again, after doing the wet analysis, then I'll be starting, or I'll start doing, or I'll analyze if the colored salt is given to me. What is that particular thing? So I'll be teaching which colored salt, which ion represents in that. So basically in most, and I have to tell you, maximum of the schools colored salts will not be given. CBSE has suggested to give only the white colored salts, right? So now colored salts, it's easy to depict the cation. After this, I'll be teaching you what is meant by group analysis. Done. So in group analysis, basically we have, when I have to analyze the cations, we have important thing. First, you have to test for the zero group element. So zero group element, ammonium cation will come under zero group element. I'll be dealing one after the other. You can note it. After testing the zero group element, then you will go to group 1. After that, you will be going to group 2. Again in group 2, you have two classes of cations. One is 2A and 2B. Done. After this group 2 cations, you will be testing with group 3 cations. Group 3. After that, you will go and test for group 4. If 3 is not there, you will go for group 4. If group 4 cations are not there, you will go for group 5 cations. If group 5 is not there, the last group, that is group 6 cation, is what you are going to test for. So this is the procedure. Suppose if you get, we will see what is a group reagent. Everywhere you have to remember two important things in groups. One is group reagent is important. What are the group cations which are present in that is important. After getting the cations, what is the color of the precipitate? Means when you do the confirmatory test, so confirmatory test, in this confirmatory test, you will be learning or you will be depicting what is the color of the precipitate which you got. So some you'll be getting precipitate, some you'll be getting a clear solution also. So you have to remember these three things are very important for the cation. When you go for reporting, these three things are very important. Done. After doing this, as I told you, I'll be starting with one after the other. First, please take your notebook, start writing or put the heading cation analysis, and let's start off with these three. Before I go to the main concept, one important thing, most of the students, they get confused. They have a confusion between two different terms in cation analysis. That is, they don't know what is the meaning or they don't know what is the concept of residue or precipitate and what is the meaning of filtrate. They come and ask, ma'am, what is filtrate, what is precipitate? Most of the students, nothing to get confused, student. Just see, suppose if I take, let me take a beaker like this, right? I'm going to take a funnel which I'm keeping here on the top, and I'm going to take one filter paper. So I have taken one filter paper, I folded it in the form of a cone, and I have kept it inside the funnel. So this is a filter paper, this is the funnel, this is the conical flask. Done? Fine. So now you're going to take that salt, you're going to find for the solubility, then you prepare the original solution. Okay, we call it as OS. OS means original solution. What are you going to do? The salt which is left out after your anion, you're going to take the salt, you will be testing the solubility, and with that you will start preparing an original salt. Now, when you get the original salt, suppose you are trying with the first group reagent, dilute HCl. Basically, first we have to start off with the zero group, as I told you, ammonia. If that is not there, I'll go to group 1. Let us assume I am doing one group 1 cation analysis. For me, taken the salt, tested with solubility, and I'm going to add the first group reagent, that is dilute HCl. Now what I'm going to do, I'm going to take this first group, so original solution with dilute HCl. I have to filter it. Let us assume I have to filter it. I'm just explaining the concept of which one? Concept of residue or concept of precipitate. Now see, when you are putting it to the filter paper into the conical flask, I said whichever is the solid residue, solid part, okay, the solid part which is left on the funnel is called the precipitate or the residue. Whichever is the liquid form, whatever is liquid which is present at the base of the conical flask, that is called filtrate. Don't get confused, student, because I'll be using this precipitate, filtrate or residue, filtrate every time in all the groups. So once again, whenever you're doing this, two things you have to remember. In a conical flask, the solid part which is there, or the solid part or the solid substance which is left out, the solid one is called the precipitate, which is there in the filter paper, right? And the clear solution, whatever is there, the clear liquid, which are clear of a little bit, color of that reagent which you add, which is present, where will it be? This will be the base, that is called filtrate. Done, students? So if you get this clarity, then I can start off. Now let's come back and start with the first concept, that is wet analysis of cations. Right, so welcome students. Now what did I told you? I have already given you the basic idea of how to do. Now let's see the trick. What should you do when you get your cation analysis? I'm going to start with the wet analysis. So wet analysis, as I told you, will be testing with cold water, hot water, dilute HCl, nitric acid, and sometimes aqua regia also. Done. So most of the schools, they give you water soluble salts. Few they add on with the water insoluble salts also. Not a problem. Sparing these soluble salts also, we'll see. So basically I have divided into 3 different test tubes here. Now the first test tube is where we are going to learn about the salts which are soluble in water. Okay, right. So immediately as soon as you add it will be soluble in cold water, and some little warm, if you test it lightly, if you warm the test tube, it will be dissolved, or you'll get a clear solution. What are those salts? So I have divided into soluble in water salts, sparingly soluble in water, and insoluble in water. Okay, so I hope you know what is sparingly soluble. Done. So what are the salts which are soluble in water as soon as you add? Let us assume this is a test tube and you have taken the salt here and you have added water to this. Done. The salts which are soluble in water, first one, if I have to see here, acetate. You have to be very carefully observing. This is one test tube, second test tube, and third test tube. In acetate, all the cations, whatever are there, okay, all the cations which you have studied, we are going to study different cations like ammonium, sodium, potassium, rubidium, cesium, okay, rubidium, cesium, that they will not do. Calcium, magnesium, your barium, zinc, aluminium, okay, all these cations of all the groups, done. All the cations with the acetate, when they are in combination with acetate, they are soluble in water. But what is the exception? If the acetate is made up of silver, means if the salt is silver acetate, or if it is mercurous acetate, mercury is an us form here in mercurous acetate. So silver acetate and mercurous acetate are sparingly soluble in water. So whenever you get an acetate or in the combination and the cation, remember all the acetates are soluble in water except silver acetate and mercurous acetate. So you can note it. First you'll write. Suppose if I go with the next one, just see here, fluorides, sodium fluoride, potassium fluoride, ammonium fluoride, silver fluoride, stannous fluoride, and mercury, HGF. All this are cations if the fluorides of this are soluble. What is insoluble? Let's see. Any fluorides are insoluble, sparingly soluble? No. Here we have something, right? Just see here. Here these specific cations are soluble in the fluoride form, but other than this, the rest fluorides are insoluble in water. So what you have to remember? These fluorides are soluble in water. Other than these cations, whatever are there, they are all insoluble in water. Not even sparingly, insoluble directly. So you can rule out as soon as you test it. Okay, that means in this particular salt maybe this, remaining all, what are they? Barium not there, calcium not there, your zinc is not there, aluminium is not there, all these are insoluble in water. So one, you will get a clear picture. Let us come back. If chlorides, same thing. Here in chlorides, all whatever are there, all if the salt is chloride in form, if the anion is chloride, all the salts are soluble. Do we have any exceptions here? All salts with chloride anion combination are soluble, but salts like, see here, salts like silver chloride, salts if the mercury is in us form, that one, tellurium is in us form, that chloride, copper is in cuprous chloride, rather cuprous chloride in that form, BiCl3 and SbCl3. These salts are insoluble in water. Once again, let us come back. Salts like salts or the cation which have chloride combination, all will dissolve except these. So you have category which is soluble are these, which is not soluble is this. Easy, isn't it? Let's come back and see next. Bromide also same thing. All bromides are soluble in water except, see here, anything is there? Not there. That means every bromide anion, whatever is their combination, compulsory it will be soluble. I have not written any bromide here. I have not written any bromide there. So confirmed, all bromides are soluble. Let us come back to iodide. Iodide, if I have to take iodides of sodium, potassium and ammonium are soluble in water. Is there any variation? Let's see. Check, not there. Check here, not there. That means all iodides are soluble, all bromides are soluble in water. Now, let's come back to nitrate now. In nitrate, all nitrates are soluble in water. Now, what is different? Let us see. Is there anything sparingly soluble? Not there. Here, yes, it is there. See here. All nitrates are soluble except bismuth nitrate, mercurous nitrate, mercuric nitrate. Some schools may test that. So such particular thing, it is insoluble. So you have to see this, compare with that and this. Easy, isn't it? Now let us come back to phosphate. So phosphate here, sodium, potassium, ammonium phosphates, they are perfectly soluble in water. Do we have anything here? No variation. Do we have anything here? No variation. So they are perfectly soluble Sodium, potassium, ammonium phosphates, perfectly soluble. Done. Sulfate. Here I have given all sulfates are soluble. Means there will be testing with soda carbonate extract using a phosphate, and sulfates will be testing with soda carbonate extract. That also. Do we have any variation here? Yes, we have variation here. Salts like calcium sulfate, silver sulfate, mercuric sulfate, bismuth sulfate, all these are sparingly soluble. So I think you have got a clear idea. Don't get confused. Clearly see. First test tube, second test tube, third test tube. First test tube is soluble in water. Second test tube is sparingly soluble in water. Third test tube is insoluble in water. Done. Ma'am, this is really confusing me, or I can watch it, write it 2 or 3 times, you will get to know. Now let's come back and see what actually after testing. Now I know which salt dissolves in which one. I can prepare the original solution, OS with me. Now after preparing the original solution, I'm going to keep it ready in the test tube stand and start with the group analysis. So I told you, once your original solution is ready, first concentration is you have to test for ammonium cation. After that only you have to go to remaining. But now for the procedure wise, I'll be teaching you the group 1 cation, then go to group 2. I'll tell you what is the procedure, then we'll do the ammonium cation. But in exam, remember students, first test for ammonium cation, then only go for 1 to 6 groups. Let's start off with group 1 analysis. The whole idea perfectly, keep noting it, nothing to get confused, very easy, have confidence, we'll do it. So we have seen the wet analysis, what are soluble in water, what are sparingly soluble, what are insoluble. Let's see one more. The cations, this is a list of cations which are insoluble in dilute HCl and HNO3. I told you, right? So water it is not. This is one more idea which you can remember. So calcium fluoride and these salts, AgBr, Hg2Br, Br2, silver iodide, mercuric iodide, Hg2I2, Hgi2. Okay. So these 3 combinations are slightly soluble in water, slightly soluble in this one, not water, slightly soluble in these 2, right? These 2 are insoluble. Let us come back to one more, barium sulfate and lead sulfate. These are insoluble in HCl or HNO3. So this also can be used for ruling out. Instead of testing with water, take that dilute HCl and see that you can get one analysis of the salt. Now let's, as I told you, let us start off with the first one, that is the qualitative analysis or the group analysis, starting from group 1. Right. Now let's start with the actual analysis. Now I've done the wet analysis. I know which is the salt is soluble in which one, whether it is cold water, hot water, HNO3 or HCl, as I told you. Right. Now after knowing the solubility, a little bit idea I have got. Okay, not a little bit, I think most of the students then and there they would have got thing directly you can go to confirmatory test. But according to the procedure suggest, now I've prepared the original solution with whichever is the solubility. The first important thing you have to remember, most of the Viva questions you'll be getting it from here only. What is that? See, suppose I'm the examiner. When the student comes with the confirmatory test, first the examiner asks you, what are you reporting for? So you will be telling, ma'am, I'm reporting for lead chloride. So the examiner will ask you first important thing, what is the first group reagent? So remember, for us, after preparing the original solution, what am I going to do? I am going to take, as I told you, we have from NH4 plus, after that group 1, group 2, group 3, group 4, group 5, group 6. First, I am going to take that, and I also told you what is the precipitate or the residue or the filtrate. To that, I am going to add the first group reagent, that is dilute HCl. So dilute HCl is the first Viva question. It is the first group reagent. So when I add to the original solution dilute HCl in slight excess, I'll be adding little more with the dropper. So and then I'll filter it. As I told you, when you filter it, there are 2 parts which you get. One is the precipitate or the solid residue which is there on the filter paper, and one more thing which is there is the one which is present at the base of the test tube within the conical flask is a filtrate. The liquid form is a filtrate, the solid residue the precipitate. Important thing. After adding the group 1 reagent, once you filter, the solid residue what is there on the filter paper, it will contain the first group cations, that is silver, mercury and lead. So these are the first group cation. Viva question number 2. Once she has asked you what he or she has asked, they've asked you what is the group reagent, done. Next, they will ask you how do the first group this is salt precipitate out, right? You have to say, because we have added dilute HCl, the first group cations, they precipitate in the form of chlorides. Silver chloride, mercury chloride, lead chloride. So first survivor question number 2, because we have added the HCl, dilute HCl as a group reagent, the first group cations, they precipitate as chlorides. All are white in color. The precipitate will be white in color. So once I get the precipitate white in color, I'll start with individual confirmatory tests. There are 2 confirmatory tests. For some it is 3 along with the reactions. Hope it is clear. Come back again, recollect. Once you get the original solution with the water or HCl or HNO3, you will be going to the next step, that is the group analysis. So ammonia, as I told you, I'll teach at the last. Come back to group 1. I have taken that original solution and I started adding the first group reagent, dilute HCl. How much? Little bit excess. And I have filtered it. Once I filtered, as I told, 2 parts you'll get. On the filter paper, the solid part is a precipitate, and the filtrate, which is the clear solution at the bottom, is a filtrate. So here I have got 2 things done. So the one which is there at the top of the conical flask, here this one is the first group cations, which are precipitated in the form of chlorides. These 3 are the cations. The one which is there at the base, this is the filtrate, isn't it? So this filtrate has the remaining cations, that is group 2, group 3, group 4, group 5 and group 6. Done? Yes. So from here I'll be taking this precipitate and doing individual confirmatory tests. Over. Step 2. Now I've not got any precipitate done. Then I have to go to the next form. That is, I'll be taking that whatever filtrate is there. Yeah, I'll be adding to that. The next important thing, this is a step. I'll take out the filtrate, separate it, and see here. What I'll do, evaporate to almost dryness. I'll be evaporating, taking that in the test tube, and I'll heat it and I'll start evaporating. Okay, then what will you do? Again, I'll be adding dilute HCl and then pass H2S. So H2S, now we're getting hydrogen sulfide pellets also in most of the school. So I'll be adding H2S and again filter it. Hope you understand, student. Add, filter, add, filter, add, filter. Done. When you add this H2S and you filter, again you'll be getting 2 things. One is the precipitate, which is at the top, and one is the filtrate. The filtrate, which is at the base, contains group 3, group 4, group 5 and group 6. Now, the precipitate which is there on the top in the funnel, whatever is there, suppose after adding HCl and H2S to that, if the precipitate or this particular thing what is there, if you get a black PPT in the or black residue in the filter paper, that particular thing, you may have group 2 cations. What are the group 2 cations? Now, group reagent is H2S. Group cations are mercury, lead, bismuth, copper, cadmium, arsenic, antimony and tin. Most of the schools will give lead only. Copper, they will not give. Arsenic, poisonous, not given. So here, what is the important Viva question? Question number 3. Question number 1 is this group reagent. Question number 2 is what way they are going to precipitate out. Question number 3 is what is the group 2 reagent? That is hydrogen sulfide. Question number 4, Viva question. In what way do they precipitate? So remember, group 2 cations always precipitate in the form of sulfides. Group 1, chlorides. Group 2, sulfides. See here, I have written the sulfide form of all. All these are group 2. So now what will you do? I've got the precipitate, black precipitate. Now you'll start performing the confirmatory test for each. You'll be having confirmatory 2 or 3 confirmatory tests. Over. Suppose if I don't get group 2 cation, no precipitate ma'am observed. Now you have your filtrate, isn't it? The filtrate is counting. So here 1 is ruled out, here 2 is ruled out. Now come to the 3. The clear solution, the solution of the filtrate which is present at the base of the conical flask, it has group 3, group 4, group 5 and group 6. What will I do now? I'll take out the filtrate. From that to that filtrate, I'll be adding nitric acid. I'll be boiling it. Then I'll be adding the group reagent, that is here ammonium chloride and ammonium hydroxide. Understood? So Viva question number 1, Viva question number 2, Viva question number 3, Viva question number 4, now Viva question number 5. The examiner will ask you what is group 3 reagent. Group 3 reagent is, along with the HNO3, ammonium chloride and ammonium hydroxide. So filtrate is taken out, you added these, boiled nitric acid, you added nitric acid, you boiled, then you added ammonium chloride and ammonium hydroxide. You're mixing it up. Now again you will be, if the group 3 cations are present, again you will be getting some precipitate. Correct? No? If the cations are present, you will get a precipitate. Then once you observe the precipitate, you will take a funnel, you will prepare take the filter paper, prepare a cone and put it in that. Then again you start filtering it. When you filter it, again two things you will get. On the top, on the filter paper, you will get a precipitate or the residue. At the bottom, you will be getting the filtrate. The precipitate, whatever you are getting for group 3, remember, the precipitate might contain group 3 cations like aluminium, chromium, iron, most important. So group 3 cations are aluminium, chromium and iron. Right? So now the examiner will ask you, so group 3 reagent you have told. Now in group 3 cations, how do they precipitate? They are going to precipitate in the form of hydroxides. Understood, students? Now let us come back and little bit add on something or summarize, then go to group 4, group 5 and group 6. So what did we learn? We said first group cations, this is group and this is the group reagent, and how do they precipitate. So let us start. First group 1, what is a group reagent? Dilute HCl. How do they precipitate? In the form of chlorides. Right? And what are the cations present? This. So you will write, you will prepare that. What are the cations present? Silver, mercury and lead. Done. Let us come back to group 2. Group 2 reagent is H2S. How are they precipitating? They are precipitating in the form of sulfides. And what is that? They are going to, as I told you, what are the cations present? Hg, Pb, Bi, Cu, cadmium, arsenic, antimony and tin. That is also over. Now I am coming back to group 3. In group 3, what is a group reagent? Ammonium chloride, ammonium hydroxide. So you are adding HNO3 also. HNO3, ammonium chloride, ammonium hydroxide. Now here, how are they precipitating out? They are precipitating in the form of hydroxides. And what are the cations present? Cations present are aluminium, iron and chromium. So because there is no place I have written here, this is the first column, this is the second column, this is the third column, and this is the fourth column. So many Viva questions covered. Let's start off with the fourth group. Right. So now we have seen what to do. Like if group 1 is not there, how to do group 2. After group 2 is not there, how to do with group 3. So this is where I ended in the last video. Now, so here I have got this precipitate and I will be doing the confirmatory test for everything. Suppose if I am not getting any precipitate, the filtrate whatever is there in the bottom of that conical flask, that will contain group 5. Now group 3 is over here. Here left over will contain group 4, group 5, group 6. Now next I will be going to testing for group 4. Now next Viva question, what is a group reagent? Now again you will be passing H2S and you will filter it. When you are adding this group reagent, again, suppose if group 4 is present, here group 3 was present, here group 4. Suppose if group 4 is present, they start precipitating out. Now what is a group reagent? H2S. What are the group cations which are present in fourth group? Zinc, manganese, nickel. Zinc, manganese, nickel are group 4 cations. How are they precipitating? They are precipitating in their sulfides. First we have written chlorides, like that one after the other. Chlorides we have seen. Now in third group we have seen hydroxides. In the second group we have seen sulfides. Chlorides, sulfides, hydroxides and again sulfides. So this is your Viva question. Over. Now once I get this, COS also, I'll be doing individual confirmatory test. Done. Suppose if that doesn't contain, or if you're not getting anything, now I'll be taking the filtrate. To this filtrate, I'll be adding these group reagent. Now what should I test? I have to test 1 is over, 2 is over, 3 is over, 4 is over, and I have to test for 5. I'll take the filtrate, I'll add the group reagent, that is H2S is there, isn't it? I'll boil off, I'll put it on the Bunsen burner, I'll boil off H2S, concentrate it, then I'll start adding ammonium carbonate and ammonium hydroxide. After adding the group reagent, again what do I do? If I observe a precipitate, I'll start filtering it. When I filter it, if the precipitate or if you get a precipitate with these things, it may contain group 5 cations. What are they? Barium, strontium and calcium. Because we are adding ammonium carbonate in excess, group 5 cations are going to precipitate in the form of carbonates. Barium carbonate, strontium carbonate, calcium carbonate. So one more Viva question. Two things, group reagent, precipitate, form. So first is chlorides, next is sulfides, third is hydroxides, fourth is sulfides, fifth is carbonates. Done. That is also over. Ma'am, you're not getting any precipitate. Come back. Whatever filtrate was there in that, to that filtrate you're going to add, now this is the last group. So sixth group, this is your group 6. So sixth group cation is magnesium. To that I'll be adding here, just see, two things are there. To the last, whatever filtrate was there, because fifth I got here, I'm left with the filtrate. I'll take that filtrate from the base of the conical flask. I'll be adding magnesium ammonium phosphate. Then if a precipitate forms, it will indicate that magnesium cation, that is group 6 cation, is present. I'll be taking that for further confirmation. If I add ammonium hydrogen phosphate, suppose if I add hydrogen phosphate to this filtrate, if I get a precipitate, that means sodium cations or potassium cations are present. Group 1 cations, alkali metals. Lithium, sodium, that is your group, this one, isn't it? Group analysis periodic table you would have seen. Lithium, hydrogen, helium. Okay, how do we do? Hydrogen, helium, lithium, beryllium. So your lithium, so hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, potassium. So here I can test for sodium cation, I can test for potassium cation also. How do I test? I can test it by using ammonium hydrogen phosphate. So hope students this is clear. I'll start off with the now clear explanation of group 1 analysis. So I'll be uploading group 1 analysis, group 2, group 3, group 4, group 5, group 6 first with ammonium also. Let us come back. So don't get confused. Two things, group reagent, precipitate, cations present, in what form they are precipitating is important for you all.